Hello, this is Carl Rayberg doing my presentation for Network Systems itd1223, 1223. Dr. Fillmore Gwynn is the professor. I have chosen to present Transmission Control Protocol, also known as TCP for short. This is one of the protocols we learned early on in the class. The definition of TCP, Transmission Control Protocol, is Transmission Control Protocol is a network communication protocol designed to send data packets over the internet. TCP is a transport layer protocol in the OSI layer and is used to create a connection between remote computers by transporting and ensuring the delivery of messages over supporting networks and the internet. This comes from the website, it actually should be Techopedia, not Technopedia, but this comes from that website. So it is the protocol designed to send data packets over the internet. It is part of the transport layer. If you were to look at the OSI model, this is part of the transport layer, and it creates that connection between remote computers by transporting and ensuring the delivery of messages. So it's the protocol used to make sure that the packets that are sent get to the right place. So it's a pretty important protocol to have. Another definition, another way to explain TCP or Transmission Control Protocol is that it is an important network protocol that is used in the transmission of data over networks. A protocol in the context of networks is a set of rules and procedures that govern how the transmission of data is carried out so that everyone in the world, independent of the location, software, or hardware used, does the thing the same way. TCP works together with IP, which stands for Internet Protocol, and a well-known duo called TCP/IP. And Yunoth is the person who put this definition on his website. That's where I got this particular definition. So again, to break down this explanation, it is a protocol. Protocol is usually a term that's used like in the military to designate the way certain things are to be done. Whenever an event takes place, there's certain procedures that have to be followed in reaction to that event. That is the protocol. For example, if there is an attack on the United States, the military would lock down probably the commercial airlines, like on September 11th, 2011, they would lock down the commercial airlines so they couldn't fly, and then they would send in military to help secure any areas, and so on and so on. Whatever the protocol would be for an attack on the United States, that's what the military would do. They would have their procedures or protocol set in place to take care of that event in response to what happens. Well, protocol in this sense, when you're dealing with networking, is really pretty similar. There's rules and procedures that, as it says in the explanation, that govern the transmission of data. And when you have millions and possibly even billions of people using the internet all over the world, of course the United States, but we know that the United States, although we want to think we're the only ones here, we're not the only country. So all over the world they use it, and you've got to have some kind of protocol, something in place, so that if someone in Bangor, Maine is using the internet and someone in Beijing, China is using the internet, if they're going to access the same websites, how are they going to receive the packets they need? And there's not going to be jumbled data, or they're going to actually get to the site they're wanting to get to. That's what the TCP takes care of. It's that transport layer. It's that part that works with Internet Protocol to set up the certain rules to govern the way people access the internet so that people can access it. You can get the web pages you want whenever you type in a URL. For example, if you go to NFL.com, you want to be able to get the National Football League and read about it and get the information from that site. And it's the TCP layer, the transport layer, that helps to ensure that you reach NFL.com and not, Barbie.com or something like that, or heaven forbid, MLB.com. You want to get to the website you're trying to access, and you don't want a bunch of garbled data. And that's where the protocol comes in. It's a step of procedures that governs how that transmission is done. So if you look at the layers of the TCP/IP, Transmission Control Protocol and Internet Protocol, these are the four basic layers. Now there is an OSI layer model that is much more in depth. It has more steps, but the TCP/IP layer that we see here, this is what the internet goes through, that the packets go through in order to get from one computer to the next. And of course you have routers and switches and hubs and bridges and things like that in between the two. But if you're going to go from one computer to access the server, which a server is essentially a computer, you have to go through this TCP. You have to go through this protocol. And here it goes from the bottom to the top. So the bottom you have the network access layer, the internet layer, the transport layer, and then the application layer. These are the four: network access, internet, transport, application layer. The link layer, which in the above, if we go back, the network access layer, that's the link layer. The link layer, referred to as the network access layer above. It is the physical network equipment used to interconnect nodes and servers. So the link layer is mainly going to be like your modems and your routers and all the physical components that are needed to access internet. Of course, you got to have the hardware. You can't have the software without the hardware. So this is the physical layer. And you see these bullet points. At physical level, data consists of a stream of bits, sequences of zeros and ones. It defines how the bits are encoded into electrical signals by the network devices. It's synchronizing the sender and receiver at the bit level. There's line configuration, point-to-point or point-to-multipoint. Transmission mode, which is simplex, half-duplex, or full duplex. Then you have the topology, how are the routers set up, a star ring tree, etc. Mechanical specifications of cables and connectors. And then the specification of electronic factors like voltage, frequency, impedance, etc. So again, this is all dealing with, especially like the topology you see, it's all dealing with the physical layer, the link layer, getting from the hardware, so from one place to the next. So that is the link layer. The next layer is the internet layer. The internet layer connects hosts to one another across the networks. And you see the bullet points here. Packages of data are received from upper layer into datagram by adding IP header to it, which consists of source and destination address. This is used to forward the datagram between nodes and across networks. And then it performs addressing, routing, and other functions using the following protocols. The Internet Protocol, which is a connectionless protocol used for addressing hosts and routing datagrams from source to destination hosts across one or more types of networks. Then you have Address Resolution Protocol, ARP. I'm not going to read all of that, but used to resolve host hardware address. Reverse Address Resolution Protocol, Internet Control Message Protocol, and then Internet Group Management Protocol. And so this is the layer in which it goes across the networks, finding the right server, the right place to get you to your website. Then you have the transport layer. The transport layer resolves all host-to-host communication. And this is mainly where the TCP comes in. Transmission Control Protocol is a connection-oriented, reliable, and stateful protocol. It's connection-oriented in that it establishes a logical connection between sender and receiver before sending any data packets. It's reliable in that the receiver sends acknowledgement of received data, a received packet to the sender. It's stateful. Both the sender and receiver keeps track of the state of communication session, responsible for establishing termination of the TCP connection, ordering of sequence number and acknowledgement number, flow control, error, recovery of loss, and damaged packets. And then it has a high overhead, and that is expensive to have the TCP because there's so much that's involved in keeping it going. That's the transport layer. And then finally you have the application layer. The application layer is utilized to ensure communication between applications on a network. So these are the functions of it: formatting data, representing the data, process-to-process communication, and then creating sessions. These are the basics of the application layer. And so TCP, or Transmission Control Protocol, is used to help ensure the internet runs smooth. It is made up of 4 layers: the link, internet, transport, and application layer. TCP has become one of the most popular protocols in the world of the internet, and likely will remain so for years to come. And then here you have my work cited. Again, that's Techopedia, the third one there. I had Technopedia earlier, but these are the websites used to give the information that I gathered for this presentation. This is Carl Rayberg, again, Network Systems, itd1223. Thank you.